In this lecture, we're going to build on our classic sheep program that we had before. So what you might like to do is take a copy of it, or in fact just save the classic sheep scene as a new scene. Okay, so I will just create this and go File, Save As, and let's call it a classic 4 parallel. Just save that. Now what we're going to do is use parallel computing in this. So we're going to use a parallel for loop that's going to process the movement of our sheep. But before we do that, we want to make a change to the current way that the sheep are moving. If you have a look at your sheep, the prefab, we've got this move script on it. So that means that each sheep is actually looking after its own move. Going to take that out of there and put it in a centralized location. So just untick that move box, or in fact you could even just remove it altogether from being on your prefab because it's no longer needed. Okay, so we're going to go into our spawn script. Now if you want to keep a copy of the original one, then you could probably just duplicate that. So duplicate it. Let's call this spawn parallel, and then what I'm going to do is on the spawn manager remove the spawn script. I'll just untick it and put spawn parallel on there, but before we do that we need to open that up and actually call the class spawn parallel to stop any conflict. So I'll just save that, switch back to Unity, and on our spawn manager we will just drag and drop that new spawn parallel script, and we will give it our sheep prefab while we're here. Okay, so let's go back into that script. What we'll do is put an update in here, so void update, and inside that update we will move all of the sheep pretty much in one go, or within at least a for loop. So this is where I'd like to give you a challenge. I'd like to see if you can get the contents of that update loop written so that all the sheep now move using just that update and not their move script anymore. So pause the video now, and when we come back, I'll show you how to achieve that. So how did you go with getting your sheep to move the same as they did before, but only using that update loop? To do that, it means we need to grab each of the sheep prefabs that we've created, or game objects I should say, put them into an array so that we can process them. So let's create a game object array, and this will be called all sheep. And then the size of all sheep is going to be this num sheep down here. So in the start, I will actually initialize all sheep. So all sheep at position. So all sheep will equal game object, and then the size of that will be num sheep. And don't forget to put the new in front of there to create it. Okay, now all sheep need to get these instances into them. So down here where we're creating this instance from our prefab, we'll just put it into our all sheep array. So all sheep at position I is going to equal the instance. Right, now inside of update we can actually loop through all sheep and just move each sheep one at a time. So I'll just grab my for loop that I'm using, copy that, paste it down into here, and then inside of here we're basically going to use what we had in our move script. So if we just go back into Unity and open up that move script to remind ourselves, this is it here. We're translating at 0.1f, and then when we get to positive 50 in the Z, we're going back to negative 50 in the Z at a random location in the X. So I'm just going to copy all of that code, go back into my spawn parallel and put that inside of the for loop. Now instead of the this transform translate, it's actually going to be all sheep I. So I'm going to copy that. Wherever I've got this, I'm just going to replace it with all sheep I. And the other thing I'm going to do is get rid of this random dot range, and instead I'm going to put the sheep back at negative 50 in the Z, but keep it at its current X location. The reason being is that creating random numbers inside of the ECS system and parallel programming stuff is not as easy as you might think. You can't just go random dot range when we get to do that. So I'm going to take it out now so that we don't use it. And we will cover random numbers in the ECS a little later as it's a more complex topic. Okay, so let's just put all sheep, and we want all sheep I dot transform dot position dot X in there as the X position for the sheep. Okay, so we've got that, and let's just save it. Now we haven't done anything different really other than classic Unity. It's just we've moved our move scripts and we've got rid of them completely, and we're just moving all of the sheep inside of the update. So let's go back into Unity, and we're going to press play. And you're going to see basically what we had before, but when the sheep disappear from the top, they're going to come back in their same X position that they were before. So they're initially set up as random, but then we're not using the random afterwards. Okay, so let's have a look at our stats and see what we're getting here. Our FPS, or my FPS in this case, is around 32, and that's better than what we achieved before when we turned on the GPU instancing, but only a little bit. So we haven't really saved anything by doing the move script inside of our spawn. But the reason I've moved it is that we actually need it all together in the one place in order to perform parallel processing on it. All right, so we've now got that. Let's go back and adjust it so that it uses parallel processing. Now, being able to perform parallel processing with a parallel for loop in Unity is not something that's new. So it's actually been there for, I think, since .NET 4 was introduced into Unity, but because it's not really, I guess, spoken about a lot in the Unity forums, and the people who are learning Unity who don't have a in-depth idea of how C# works, you might not have thought of putting those sorts of things together. So I'm going to show you how to do that now. And again, this is not something that's new to the ECS dots stuff, but it is definitely fundamental to how we get things to run really quickly and optimize our code. So what we need at the top here is to be using Unity engine.jobs. And we also want to be using unity.jobs. Now, as the present aim of what we're doing is to show you just how we can increase the optimization by building towards using the dots in our projects, I'm not going to go into a full-blown explanation between the difference of what you've got now and the difference of our parallel for that we're about to put in place. But I will give you a little bit of an overview, and we will get into depth with it later on. So what we're currently doing inside of this update loop is that we're running our game. It comes into the update loop. Now the game actually can't put a frame to the screen until it's finished one update. So each update, a new frame goes on the screen. The more stuff you've got going on in update, the slower your frames per second is going to be. So if in this case, if we increase the count of sheep that we have, then we're going to start dropping the frame rate, because it's going to come into the update and then it's just going to sit there on the same frame while it loops around in here. So the longer it loops around in here, the lower the frame rates is going to be. What we do with our parallel computing is we also loop around all of our sheep, but we don't do it one at a time. This way is doing it one at a time. With parallel computing, we actually push through more sheep at a time. So say instead of one at a time, we might be able to push through 8 at a time, or we might be able to push through 16 at a time or 32 at a time. And how many you can actually push through depends on the hardware you've got in your actual computer and also the number of CPU cores that you have. So essentially, instead of having like one pipeline that you're pushing one sheep through at a time, you've ended up with like 64 pipelines that are all running at the same time, and therefore you can process things way quicker. So that's a really quick overview of what we're working towards with this. All right, when we come back in the next video, we will convert this into job code.